And now I'm going to show you the same car which I showed you in the previous video with the sensor. And for this project I've used an ultrasonic sensor, which is right here, and it is connected to the 6 pins of the motor shield, which is right here. And there is quite a limitation on the number of pins on this motor shield, so you can take different motor shields, and the connection is just the same, but there might be difference in the pins which you have to connect. And um, so this um, motor shield has 6 pins which are at the top, which is right here, and it is plus, minus, S, and there are the top three rows are the same. So for this, for the S, they are the pin numbers 10 and 9, digital pin 10 and 9, and the plus and minus are GND and VCC of the VCC and Arduino board. So for this ultrasonic sensor, I've connected the blue wire to the blue wire, which is the echo pin, to the topmost pin, and the green wire, which is the trig pin, at the lower pin of the S row, S column, and the yellow wire is the GND, I mean VCC, which is connected to negative, and the purple wire is the GND, which is connected to negative. I mean positive, the positive. So, whenever an obstruction comes in the path of the ultrasonic sensor, the ultrasonic sensor signals to the motor shield to stop both the motors. So both the motors stop for some time, just 2 seconds, and they will rotate in a right angle turn. I've only integrated right angle turn and not yet left angle turn. You can integrate them into the circuit, into the code, and after taking a turn, the motor will will signal the motor to go forward. So I'll show you the code later on, and you can take a different motor shield and add this to this circuit using a motor, or a servo motor. A servo motor is like a motor which can turn left or right, and if you connect it to if you add this on top of the servo motor, it will act like a radar which will keep rotating left and right. Thank you. So now this is the code of the sensor card, which includes the Adafruit motor library, which I showed you in the previous video, and as usual the declarations and the echo pins and trig pin for the um, ultrasonic sensor. So now this is a new data type I have written here, which is called long, which is a larger data type of integer, which has more memory. So I have declared it in duration as the time, and distance in integer. So I have declared the baud, the pin mode of the trig pin, and the pin mode for the echo pin, and I have declared the speed for the motor 1 and motor 2. So now I have written here distance is equal to get distance. So you may be wondering what is get distance. It is a function which I'll show you, which is at the bottom of the loop, which I'll explain it later on. And in serial.print, it prints the distance and the value of the distance and in centimeter. So it will check the condition. If distance is greater than 0 and distance is lesser than 25, if the this which means that if the distance is too close to the ultrasonic sensor, it will avoid the obstacle. I'll explain that too. If not, if the distance is greater than 25, it will just move forward.
with a delay of 0.2 seconds. So this is a get distance, and the digital write for the trick pin and the delay and all is written here. So uh, this is as usual, but now I have added something new, which is 3000. And if duration is equal to 0, it will return 999, so that the Arduino, so that it will just ignore that level of distance. You can add it or remove this code. So mine just works. I added this because mine was not working for a while. So now, as usual, the formula, and it will return the distance of the get distance function. So the purpose of get distance is to find the distance of the Arduino, of the ultrasonic sensor, and give it back to the loop function, which is right here. And in void move forward, it is just the same small function. Motor 1 dot run forward. Void stop motors, which is release for both the motors. Rotate right, which is forward backward. Rotate left, which is backward forward. So in avoid obstacle, I have written only rotate right. You can also choose rotate left also. So these are the delay seconds. And now we'll go back to the loop, and it will go to the avoid obstacle. If it is not supposed to avoid obstacle, it can just go to move forward directly. So you can also add a servo motor to this code by making the ultrasonic sensor to rotate left and right, and if it's found anything in front of it, it should rotate. And there is even a code and there is even a code in GitHub, I think, where you can get the code for the ultrasonic sensor, which rotates left or right. If there is any gap in the left, if there is any space in the left, it will move in the left space. If there is any right, they will move in the right space. Thank you.